Welcome to Impulse. Renewable energies play a central role when it comes to reducing carbon dioxide emissions and slowing down climate change. Around a third of global electricity consumption is already covered by renewable energies. Almost half of this energy is generated from hydropower. Today we look at two forms of transforming the power of water into electricity, talk about the existing challenges and how digitalisation can help us to use hydropower more efficiently in the future. CVA is one of the leading producers of renewable energy in Italy. 90% of the approximately 3 billion kilowatt-hours that the company from the Aosta Valley produces each year come from a total of 32 hydropower plants which are spread throughout the valley and sometimes difficult to access. So it's a good thing that the company has found a solution to monitor the status of the plants centrally.
CVA si definisce rinnovabile da sempre, è un gruppo industriale totalmente di proprietà pubblica della Regione Autonoma Valle d'Aosta, leader nella produzione da fonti rinnovabili. Siamo il quarto produttore di idroelettrico a livello italiano e il quinto da fonti rinnovabili. Abbiamo oltre 1,2 gigawatt di potenza di produzione di energia elettrica e produciamo ogni anno oltre 3 miliardi di kilowattora totalmente rinnovabili.
La Compagnia Valdostana delle Acque si è sempre occupata e dà grande attenzione alle manutenzioni e alla salvaguardia dei propri impianti. Dobbiamo conoscere bene lo stato di salute dei nostri gruppi di produzione idroelettrica. E qui entra in gioco proprio FM, perché al di là dei numerosi sensori, delle diverse tecnologie che abbiamo installate di FM per il monitoraggio dei flussi, per il monitoraggio delle temperature, abbiamo trovato con FM una ottima collaborazione per quanto riguarda i sistemi di vibrazioni. Prendete in considerazione una centrali idroelettriche sono in caverna, sono in luoghi umidi, spesso nei climi alpini raggiungiamo temperature molto fredde e in questi anni non abbiamo mai avuto problemi con questo tipo di tecnologia, quindi siamo molto soddisfatti.
Con IFM collaboriamo ormai da diversi anni in modo proficuo e già su 22 dei nostri impianti abbiamo scelto le loro soluzioni chiave in mano per quanto riguarda l'installazione dei sistemi di controllo e monitoraggio delle vibrazioni assolute. Ed in alcuni casi abbiamo anche testato le loro soluzioni per quanto riguarda il monitoraggio di processo mediante protocollo IO-Link. Noi riusciamo così a raccogliere tutta questa serie di dati e portarli, indirizzarli sul sistema Moneo, grazie al quale sostanzialmente i nostri tecnici riescono ad analizzare real time in modo continuativo tutti quelli che sono gli andamenti, i trend vibrazionali. Ricordiamo che grazie all'analisi vibrazionale riusciamo a riconoscere sul nascere un potenziale malfunzionamento che, se non approfonditamente studiato, potrebbe anche portarci a un guasto nel macchinario e quindi ad una perdita economica. La scelta di andare a uniformare tutti i sistemi di controllo e monitoraggio con la soluzione IFM è dettata dall'affidabilità dimostrata nel tempo e anche dalla migliore gestione di quella che è la ricambistica a magazzino.
Sicuramente avere a che fare con un fornitore che non si limita a fornire un prodotto, ma che riesce a dare un chiave in mano, quindi a garantirti la qualità di un prodotto, ma darti anche la possibilità di far installare questo prodotto e poi anche successivamente darti un supporto durante l'esercizio delle tecnologie, è sicuramente un supporto che non tutti i fornitori possono dare.
Water, a reliable source of energy. But for how much longer? The major drought in Italy in 2022 caused the national yield from this sustainable source to fall by almost 40% and by 17% for CVA. What does this mean for the future of hydropower? I will now talk about this with Marco Cantamessa, President of CVA. Mr. Cantamessa, first of all, thanks for joining us today. In 2022, CVA produced less electricity than at any time in the last 14 years. Is this a foreshadowing of the water shortage caused by climate change?
Well, if I look at the year 2023, and if I look at the winter, the current winter, we can actually be quite confident, and we also hope that 2022 was really a low point and not a new normal, and definitely not pointing towards a downward trend. But I would say that 2022 has certainly been a wake-up call that climate change is happening and will lead to a lot of variability in hydropower production. So we will see, this is what we expect, variability between years, with years of drought and years of plenty. We will also see variability within the year. This is something we already are seeing, which means different water contributions during the months, which also changes the mix between rainfall, snowfall, and snowmelt. And this is something we have to cope with.
What are your long-term forecasts for hydropower as an energy source?
Well, we're very bullish despite these uncertainties due to climate change. You know, if you look globally and in Italy, hydropower still is the main renewable energy source. Although in some countries, it's really the lion's share. In Italy, it's about 40% of renewables, and renewables are about 40% of total. Of course, the upside to grow hydropower production is limited because you can't build rivers, of course. But there is scope for repowering, which is something we are active on. And then there's the issue of quality of hydropower as a renewable energy source in terms of continuity, predictability, and also if you've got a dam, you can actually program it and you can even use it as a storage if you add a pump. So I think that one day we will have cheap and effective storage to couple with wind and solar, which have their own batteries, but we're not there yet. I mean, we personally don't believe that the current generation of lithium-ion batteries is the final solution for utility scale. So up to the point until we will have these new technologies, I think hydropower will still have a very big role.
Do you think that digitalization will help hydropower plants to continue to operate profitably despite potentially diminishing water resources?
Oh, yeah, of course. And we're making a number of investments to make sure this is happening. First of all, we will go on deploying our proprietary plant control system, which we developed in-house, with a very close attention to the specific requirements of hydropower plants, both looking at the back end, the process side, but also looking at the front end user interface. And I must say the plants to where we already deployed the system are gaining efficiency. Second thing, we're working with universities to achieve a better forecasting ability of future production in the medium to long term, so that we can feed better data into the optimization engine that currently is working on our production planning activities. The third thing is digitalization of the plants to improve the situation of maintenance. Now, traditionally, the rule was during the winter time, you don't have a lot of water, so you can close down the plants and you can do whatever you want during the winter time. Now, given the variability I mentioned before, this is not true anymore. So we have to be better at maintenance. And one of the recent plants we renovated, we did have a digital first approach. So instead of deciding what we wanted to analyze and then deploying the sensors as a consequence, we took the other approach. We filled the plant with sensors because this way we will not have a constraint. And in the future, we will develop rounds of improvements over the way we actually do this thing. And I think this will be the right approach for the future.
CVA is already harvesting energy from the sun and wind. What role will these sources play in your strategy in the future?
Well, we've got hydropower assets for about 1 gigawatt, and this is definitely the core of what we're doing, and we still are going to make significant investments. But we've got a strategic plan for 2027 that has a very clear focus on that diversification. Our plan is basically to build a second CVA with about 1 gigawatt of wind and solar. This will enable us to compete in the market with greater stability, reducing the risks that we have with climate change, but also to smoothen our ability to produce electricity across the day and across the months. And this is very important when we deal with customers.
So how will CVA use the knowledge gained from digitalization at the hydropower plants to make efficient use of other energy sources?
Well, when you've managed the complexity of a fleet of hydropower plants interconnected with one another up in the mountains, managing wind and solar is relatively easy. Also, you also got a lot of support coming from equipment manufacturers. So I must say that, yes, we're still learning some of the specifics of wind and solar, but we do have an important, let's say, starting point on which to leverage. And I think we will be able to keep up the good work that we're doing in hydro, also in wind and solar.
So, Mr. Cantamessa, thank you for your detailed and exciting insights, and thank you for joining us today.
Thanks to you. Bye-bye.
Bye-bye. According to IPCC calculations, the wave of the world's oceans alone contain 32,000 terawatt-hours of energy per year. By comparison, global electricity consumption in 2022 was just over 25,000 terawatt-hours. So what could be more obvious than harnessing the power of waves? That was the thinking of CorPower, which has been working on a wave energy converter since 2012. I now talk to Todd Jonsson from CorPower about the company's goals and the challenges of utilizing wave energy. Now guess where he's waiting for me. So Todd, thank you for inviting us here.
Welcome.
This is really fascinating. I'm a bit overwhelmed. This is so huge. Mm. Can you explain us a bit, or can you give us some facts and figures about this boy?
Yeah, it's a rather large device, as you can see. It's 9 meters in diameter. It's rated for 300 kilowatts continuous power production, and it can operate up to 8 meters of waves. We are installed in 43 depth meters here, so yeah, that's in short.
So I mentioned before already, there is so a massive potential of harvesting wave energy and use it for electrification. Mm. Why don't we already see more, or at least why don't we see wind wave farms across the oceans? Why are we still in the development phase?
Yeah. For sure, many companies have tried, but it is a harsh environment out in the ocean, and I think many companies face problems in the storms. So storm survivability has been a limiting factor, and also maybe the size of the device. They tend to be really, really big to survive the storms, and then you lose that economic and cost of energy that you need to have to be competitive.
Okay. So outside we saw windmills, and we all know offshore wind parks. Yeah. Are you a competitor to them? Will you try to get shares of them, or can you already say you are as price competitive as offshore wind farms are?
Well, as all new technologies, this is brand new. It doesn't really exist on the market. It will be more expensive in the beginning, but pretty fast we can come down to be competitive. Foreseeing that we compete with offshore wind maybe 2030 or around that, and then coming further down to 2040, we will be competitive also with onshore wind in a way that we will improve the power rating in each device, we will reduce the cost, we will improve a little bit step by step the lifetime of the technology, and all of these things together will get the cost of energy down. Quite important factor that we can produce with a much more consistent production profile, meaning we can probably produce when there is no wind and sun, and that has a certain value, reducing need of storage of electricity and so on.
Okay, so it's maybe more a third part of the whole sustainable energy production, and not just competitive part.
No, I'm sure we're not competing. We need a lot of energy in the future, and this is complementary. And to have different production resources together, I think it brings these. It can fill the gaps that we have from wind and solar right now. So it's important.
Yeah, and it also can fill the gaps maybe between the wind parks, as I saw here outside. Huge distances between each wind turbine, but many boys outside. So what area would you need to produce maybe the same amount as a wind park?
It's true, Philip. Several customers are projecting now farms where they combine wind and wave. And we can install our devices with some 150 meters in between.
Okay.
So this means we can be more condensed, and we can produce 3 to 5 times more energy per square kilometer compared to offshore wind, and I think that's quite efficient. So we can make use of the space better, I guess.
Yeah. Okay, perfect. So you said you was testing at Portugal through all the storms there, but it's not only putting the boy outside and coming back after some weeks and see how does it look. You're also collecting data from inside. We can also see here some IO-Link stuff, so some IFM sensors and masters. So how important are these values for you for the development and later on also to survey, to monitor the status of the buoys?
Yeah. Right now in the early stage in Portugal, we want to verify our design. So we are taking a lot of data and measurements now from the first devices to verify. We have made a simulator, a digital twin that we have in Stockholm, and we have verified it first through dry testing in the world's biggest wave simulator. So we were running it there to calibrate the simulator, and now we calibrate it again. So we have a lot of sensors now. It's very important for us. Going forward, it's more of to understand the status of each device. When we'll have several hundreds or maybe thousands of devices out there in the ocean, we need to understand the status of each of them, take action from shore, or take the right priorities when we do offshore maintenance.
Yeah. Okay, so you're thinking already about condition monitoring in a large scale. Yeah.
It's obviously necessary for us to keep good control of the devices in the ocean. So that will be an important step forward, learning what is normal and what is something we need to act on. A development we want to progress together with suppliers like IFM.
Yeah. Okay, great. So, to have the big picture around, to have a wrap around it, what are your plans? What are your goals? When will wave farms be named in the same breath as windmills or solar energy for sustainable energy?
Yeah, I think we have put a lot of the big challenges behind us by proving the technology. First in half scale, we've done that in Scotland, and now in full scale in Portugal. We have survived 4 large storms with waves up to 18 meters. So I think that evidence is a big step forward for the wave energy sector for sure. I think also we need to transform and inform people, decision makers, politicians, that this is we want to change the mindset from being a potential future promising technology to that this actually exists. You can see it in Portugal. We're producing electricity to the Portuguese grid. So it's a mindset change we're looking for.
All right, perfect. Todd, thank you once again for inviting us here.
Yeah.
And we will now have a look. How does it look in Portugal, and how CorPower uses IFM technology for their buoys? See for yourself.
We are now in CorPower's machine hall in Västberga in southern Stockholm. And here we are assembling and testing our first commercial scale wave energy converter, the CorPower C4. So CorPower, we are a developer of wave energy converters with a new type of high efficiency machines that converts ocean waves into electricity. So the challenge with wave energy, why haven't we seen commercial wave energy in the world until today, has been to design devices that are, number one, robust enough to survive the toughest storm in the ocean, and number two, to produce enough electricity compared to their size and cost. And historically, devices have either broken in storms or they've just been too large or too costly compared to what they could produce. But we've taken a dramatic step in improving that. So we made these devices that are naturally transparent and protected in storms, and that produce about 5 times as much energy per the amount of equipment that you need to install in the ocean to do it. So it radically improves the competitiveness of wave energy and makes it very robust.
So since our device is in the ocean and there are pretty harsh conditions, we can deal with some vibration, and so we like our sensors to be very vibration resistant. Also, since we don't like to go there, it's pretty far out, we want to have remote access to all of our device information, both for control and for monitoring purposes. So we use the IO Master, EtherCAT IO-Link IO Master, and we use pressure sensors, temperature sensors, flow, level sensors, humidity, and electronic circuit breakers. And we have all our sensors connected, so we have direct access through the IO-Link communication to all our sensors and get the most data out of those. We're now in a dry test mode, and so we are simulating the movement of the ocean onto our device, and we analyze the data that's coming back from the device, all the sensors, and through the IO Master. We're using here also Moneo to set up the devices and to analyze some of the data coming back from it.
We start our cooperation with FM when it was located in university. We're looking for a supplier to have a possibility to do the monitor of the system. Based on that, we see EFM have everything, and this was the reason to actually choose that.
So Mohamed Al-Qadari, thanks for waiting here for me.
Thank you, Philip, for having me.
So we've seen just 2 examples of centralized condition monitoring. Would you say these are the perfect examples to show the benefits of IT-based condition monitoring?
Absolutely. I really like these 2 examples because even though decentralized, they actually embody all of the challenges that we see out there. It's very difficult usually to connect the data, to find the right infrastructure, but also a lot of our customers are asking for remote access, right? So you don't want always to be close to your machines, but you want to know actually what's going around. So as you see around us building up right now, it's really about how to connect the data ultimately, right? That's the first step our customers are looking towards. And if you have connected all of these data, is how transforming the data to information, and therefore bringing all of the data together and having the opportunity even to pre-process them on an edge level. So meaning in your machine room, we're now able even to help our customers and bring this data straight into a cloud where they can now start improving machine availability, get actionable insights, how to optimize energy or improve their quality overall in the processes. So I'd say, yes, these 2 use cases really show what the challenges are our customers facing today.
So these are complex examples, and when we talk about digitalization, you always think about the complexity of digitalization. How easy is it to start with digitalization?
What we always say to our customers is to start small, right? And then to prove it, and then to scale fast. So that's part of our philosophy. And digitalization can be complex, but our aim is to make it as easy and cost-effective as possible for our customers. So to scale up with Moneo and to add more applications to it, to solve for improved machine availability, for instance, there is actually no limitations towards that.
So IFM has a long-lasting history. It's about more than 15 years already in the automation, and we have a strong presence in the OT level. Now Moneo climbs up into the IT level. How does the development of Moneo benefits from this huge experience that IFM has in the OT level?
Yeah, I mean, you have just said it. I mean, we have half a century of industry expertise, and we actually know what matters most to our customers. We know how the machines works, how the application works, what the ultimate goal of our customers are. And we brought this knowledge into our software development and trying to facilitate our customers with something that works for them as easy as plug and work. Therefore, definitely we are benefiting from these experience in our software development, but it goes both ways. We're also benefiting now in the hardware development from the experiences and knowledges that we get in the software world, knowing exactly what data actually matters to our customers the most to get the right information and actionable insights out of that.
So what would you say from your perspective as the IoT representative from IFM? We started with automation maybe 50 years ago. Now, are we at the start of digitalization, or where are we in the process of digitalization today?
I would take this question from two angles.
Okay.
I'd say from a consumer perspective, we are in the midst of digitalization. Just take the example of ChatGPT, which has been out there now for months, but you can already see the vast development and improvement in what AI can help us doing. Whereas if you look at it from an industrial point of view, I would say we are at the beginning of digitalization. Digitalization has let's say negative stigma also in the recent years because it has been quite complex. The promise of accessing the data and making useful information out of that hasn't been fulfilled yet because it was quite labor intensive. We had quite complex interoperability between existing systems and new systems. Yet another software that has been implemented. But we see now that the industry has more and more aligned towards openness, and that the understanding and positive benefits that we see from the consumer world now kicks in also into the industrial world. And therefore, we definitely see a momentum in the industrial world taking on digitalization as a chance to improve overall efficiencies.
Yeah, how can you help to change the point of view of the customer from this negativity into the benefits of the digitalization? How can you support them with that?
Speaking from IFM's point of view, our commitment towards Industry 4.0 is to make it as easy as possible for customers to solve their problems by themselves. And therefore, software has to be thought from the end, from the eyes of the customers, and also should be able to be a kickstart quite easy without having expensive consultancies around. Therefore, our approach here is plug-and-work solutions, being able to develop the hardware, knowing how the application works, and now combining this with software equips us in a unique position to serve our customers in Industry 4.0 purposes with a hands-on solution from one hand. And therefore, I'd say the first approach is to understand what the actual goals are, improving machine availability, energy consumption, or then the quality purposes, and then seeing at what stage are we in terms of Industry 4.0.
Okay, so one last question. You talked about artificial intelligence and the way of digitalization. So this connects in my head to the question: what is the roadmap of Moneo? What can we expect in the future? Will there be AI topics also in there?
Yeah, absolutely. We already serve our industrial AI assistant in the on-premise world. We are going to launch now Moneo in the cloud as first step, and then we are going to bring in AI solutions to help for all of these mentioned use cases to understand how, for instance, with a smart limit watcher, understanding when a drift is expected and predicted to occur, and bring this into our application. But also we're looking into solutions, for instance, in track and trace. So there's more to come, and we're excited about the future of Moneo.
Yeah, we are too. So, once again, thank you for being here with us today.
Thank you, Philip.
And this was it for today. Thank you for watching us. I hope you enjoyed this show as much as I did. I hope you tune in the next time again. Until then, stay healthy, take care, and bye.